name is Dorrough. I'm a software engineer at NWATechFest, and today I'm going to be talking to you guys a little bit about managing the state of your web applications, how to keep it from becoming this tangled mess. So before I kind of get into that, I wanted to tell you a little bit about myself. I've been a developer professionally for about 3 years now, working at NWATechFest. I graduated up the road at the University of Arkansas in 2016. But my entire life before that and even now, I've loved to tinker. I have more projects than I'll ever hope to finish. This 3D printer is one I'm really proud of. I ordered all the parts for it and put it together, and then I use it for other projects. If you have projects that you do on the side, I'd love to hear about them. I always love hearing about people's passions. The other thing is I love organization. I'm not necessarily naturally organized. I have to really work at it or my house is a complete disaster. But I love when everything has its place, when everything is labeled. It makes it easier for me to work on my projects. If I have a project and everything's laid out where it needs to be, I can find it super quickly and get on with my day. It's these two things put together, I think, is why I find managing the state of an application so interesting. Because when the state of your application, your web application, is organized, you know where everything is, you know how you need to go in and add a feature, and it makes your day go by a lot easier. You're not fighting to figure out how to add something. So let's talk about why we need this in the first place. Why this talk is a thing. It's just a website, right? It's just some HTML, some CSS, a little bit of JavaScript sprinkled in, easy peasy. Well, that was the case a long time ago. Here we have the Apple website in '97. Used to be a front-end engineer meant writing some HTML, maybe CSS, and just a little bit of JavaScript. Or maybe you used Dreamweaver, or maybe even Microsoft Front Page. But that's changed. Over the years, we've asked more and more of the browser, and we're at the point where we're putting entire applications that used to be reserved only for the native desktop, into the web. Frameworks like Electron has made it even easier to build applications in the web and then port them to the desktop. So I have some examples here. I picked these for a specific reason that I'll talk about a little later. The projector is pretty terrible, so I'll talk through them. The top left is StackBlitz. It's an IDE in the browser. It allows you to build full web applications straight in your browser from scratch. The top right, that is Todoist. It's a way overkill to-do list app. If you think about somebody in college that decided to make a to-do app and then never stopped. The bottom left, TurboTax. You can now do all of your taxes in the browser. You don't have to go to Staples and buy software like we used to. You don't even have to go see an account. You just do it in your browser, submit them, everything. And then Reddit, if you're familiar with Reddit, I know a lot of software engineers are. Their new redesign is a spa application, and we'll talk a little bit about that later. So, applications are complicated, and now that they're in the browser, we're having to solve a lot of the problems that we already solved before. We spent decades building applications for the OS. We had all that figured out, and then we said, okay, well, we're going to abstract it out a layer. We're going to put it in the browser. So we're having to come up with these solutions again, and they're different because we're in a different environment. They have to be cross-compatible. You have limited resources running in the browser, etc. So the scope of this talk, state is a huge topic. Literally anything you can describe having state. I can say that I'm standing here, this is down the center, and I can give a specific latitude and longitude, and I can say that I'm standing still. That can be considered state. So we need to keep the scope of this kind of reined in so that I'm not just rambling about all the different types of state that go into an application. So we're going to be keeping it to state that affects the view. So any type of state that determines what the user sees at the end of the day. So we're not talking about cookies, sessions, things like that. We're only talking about the view state. We're also going to be keeping this confined to single page applications, SPAs. The reason for that is that's what most of the very complicated kind of applications coming out are. They're SPAs, and I believe that there's been a lot of talk around MPAs and how to manage their state with frameworks like Django or Rails or any one of those frameworks that are just traditional MVCs. So with that scope, I'm going to be talking about a few strategies that we use to manage the state of a single page application. And the one thing, if there's anything that you get out of this, the one thing I want you to get is that there are multiple ways to do it. And although there may be one hot library or framework that everyone's using, we need to think about the correct tool for the job, because not every application is built the same. So that's how I kind of structured this talk as I was going through. Originally, I was just going to focus on Redux, which I will talk about, but I was going to do the entire talk on Redux and how awesome it is and why you should use it and this and that. But as I started to do that, I realized, well, it's not really for everyone, and it shouldn't be for everyone, because it has drawbacks like every strategy I'm going to be talking about. So let's get into the first one. This is probably the most familiar, especially if you're out of college or just out of college or even in college or high school or whatever. This is super common when you're first starting out. Global variables, you have a simple website or web application and you just need to share some data between two pieces of the site, and so you just throw a global variable out there and everything uses that. What it's good for? Well, quick prototyping in hackathons. If you're building an application with a hackathon, there's no reason to just like over-architect it. It's supposed to be quick. You're supposed to be proving a point. You're supposed to be saying, this is what I think we can do, and let's see if it works. So I think global variables are an okay use case for that because it's supposed to be quick. And that's an advantage. It is super easy. You just define a variable and it's good to go. And everything has access. You don't have to worry about, okay, well, I need to jump through this hoop to go get the value. No, everything has access. That's a double-edged sword though, because when everything has access to it and everything can modify it, well, everything can modify it. You can have instances where you expect one thing to be happening, but another team somewhere else built something and they said, oh, great, there's this data here. We're going to take it and we're going to modify it. Well, now that's broke something way else in the other part of the app and no one knows why because everything's global and it can turn into a huge mess. I also consider this Wild West code, mainly because it is such a carefree, like, oh, I just don't throw it out there. I'm just going to add on more and more to just the global state. I have a note here. Use it for hackathons unless somebody is expecting you to just deploy that code to production immediately. If you have that problem, write your hackathon projects in a weird framework so that they have to be rewritten. So I have a kind of a simple demo. Wow, that is really hard to read. So let me go to that. I'm using Stackblitz for all these demos, so I have the links at the end, and you can go take a look at this code if you so desire. So this is a simple to-do app. The traditional example, end all examples. And we have a component here. This top part is a component that added to do, and then we have an array of components that are actually the to-dos. So we can say, and I can add that, and so behind the scenes, go back over here to the code. Whenever we add that, we have up at the top, we have our Up at the top we have our global state, which is just a variable directly on the browser with some to-do items already preloaded into it. I'm using Vue for this because I want to get rid of a lot of the framework noise that can be involved. So we have our create component up at the top. Whenever you add one, it just pushes that new to-do into the global state. And then we have our to-do list, which just grabs from that global variable and drops it on the page. Easy peasy. So that's global state. That's pretty straightforward. Most people probably use that. Let's talk about state in the URL. This is one I like because it can offer a lot of, it's very powerful while also being straightforward and simple. State in the URL is, you can think about it as, well, you visit a different page on a website, and that URL now points you to that page. That's state. But it can also be things like query strings, parameters, any type of value that you can put in that URL. So when I say state in the URL, I'm saying you're going to put exactly what the user sees, and you're going to encode that in the URL. So what's it good for? It's good for utility applications. So applications that serve a single purpose, maybe it's a calculator type app, and apps that have no user data, no profile data, so that that URL, no matter who you give it to, is always going to present the same application. You go to that URL, boom, you see the same thing that the person next to you would see. That ties into the advantages. It's easy to share the applications. You don't have to go push it to a database and try to reload it somehow. You just share a URL, you can deep link into the site and see what everyone else is seeing. It's a single source of truth if you do it right. If you're truly pushing the entire application state into the URL, then you know where everything is, and you know that's where you need to pull from if you need to get any additional info. And it's straightforward to implement, especially with HTML5's history of push state and pop state. Disadvantages, what it shouldn't be used for, it has a low complexity tolerance. So what I mean is you can't just shove everything in the world in the URL and it's easy to work with. You can't, when you have an application that has a very high complexity, it becomes harder and harder to juggle all of the different pieces that you have to combine together and push into the URL. This one is a little bit hard to visualize, so I've brought a couple of examples of real-world applications. Wolfram Alpha, if you've been in college recently, you probably use this in your math classes. Basically, you put an equation there in the search box, and it will give you the answer, and it'll give you graphs and all types of cool stuff. This saved my mission multiple times in Cal 3. So we have x to the 1/2 power, and after you hit enter, it's a single page application, so it doesn't reload the app, but it updates the URL to include this, which is just the equation. They've encoded some of the special characters to be URL safe. But if you were so inclined, for some bizarre reason, you could totally ignore the search box, and you could put all of your equations just directly in the URL. I wouldn't do that personally because you have to look up all those special characters. But second one is Google Maps. We probably use this all the time. Well, the roads don't even show up. So if you'll notice in Google Maps, anytime you zoom around, pan around the map, when you stop, they update the URL. And they update it with the lat long and zoom. If you go to a specific location on the map, if you search for something, it'll also put that in the URL. So whatever you're looking at on the map, if you were to give that URL to someone, they would see exactly the same thing that you were seeing. So, demo again. I have rebuilt what Google is doing with their map. So here we have a map just like Google Maps, and when we pan around, we'll have the URL updates with the latitude and longitude. And we can pan around a bunch, and it continues to update. And because we're encoding this, and we're pulling from the URL for our state, we can go back, and the map will reflect what is in the URL. Let's go back here and look at the code. This is all the code, except for there's like 2 lines to actually create the map. So the first section, that's kind of the bootstrap. So whenever you visit the website for the first time, it basically parses out, is there any current state in the map? Do you have an existing latitude and longitude? If you do, it splits that out and it sets the map view to that state that's in the URL. If not, then it defaults to some latitude and longitude. The second section is what actually pushes state into the URL. We have an event that basically whenever you stop moving the map around, the dragon event fires, and it'll get the center of the map, and then it uses the HTML5 push state, and it pushes, it not only updates the URL with the latitude and longitude, but it also uses the state object that were provided to push the center coordinates into that state. And then finally, window on top state, another event listener that basically whenever you hit the back button, forward button, whatever you do to modify the browser's history, it will grab, if there is state in the browser history, it will grab that and it'll update the map view to reflect that. So a very simple way. You can imagine if you had just a simple utility that you wanted people to use that was kind of like a black box scenario where people put inputs and they get outputs. This would be a very easy way to encode the state of that. Okay, this one's a little weird. This is kind of my name that I came up with, events in localized state. The third out of 4 of the strategies I'm talking about. This is weird because this isn't really like a standardized name. I was trying to think of something, it's kind of a catch-all bucket, sort of. This is a catch-all bucket for MVC, MVVM, MVP, these types of strategies. And the reason why I call it localized state is before SPA applications started to really take off, MVC was pretty much king of strategies. Rails, .NET MVC, Django, etc. But that's a server front-end relationship there. Whenever we moved to SPA applications, suddenly we had to manage everything in the browser. Everything needs to be in your web application. And we started to kind of try and make these patterns work in the browser, but we don't have a backend, or we weren't using the backend, so it's a little weird. So to describe this, I have a couple of diagrams here. A localized state is basically if you have separate components that need to talk to each other, you don't want to directly couple them. So you create a shared service or a shared state or something for them to update that the other can read from and update in turn. So it's like a two-way communication. But you may have another component that has a completely separate state. So I'm a full-time Angular dev, and this is a huge pattern in Angular as far as using shared services and components that talk through those shared services. It's good because it keeps things decoupled. You don't have components directly trying to communicate, but there's some definite disadvantages to this. So what's it good for? Low complexity apps. If you have a web application that's not like a single purpose utility, it's not for a hackathon, but it still is not, it's not like a huge enterprise app. Like it still has a very small scope, and you don't expect it in like the next 2 years or so to go beyond that initial scope. And apps also that have unrelated features. So kind of an application that maybe the features are sandboxed. So maybe it's a collection of utilities, or a collection of forms, or something of that nature. The advantage is the state is closer to the target component. So when you're working with your components, it's easier to see how everything is linked together as long as you've kept that complexity down. And it's fairly straightforward to implement. You know that component A needs to update the state that is related to component A, and therefore component B will pull from that state. Disadvantages, it can very easily turn into spaghetti code. Once you've added your shared state, and somebody comes and you say, we want to add this new feature, and then you add that into the state, and then it just becomes this never-ending game of updating that shared service to support all of these new features. Difficult to integrate new features. I think this comes about because this type of strategy is, I see it most coming from not having an overall plan technically for your web application. So you think about the components and the features in their area and you build them in that way, and that can kind of lead to this. I still think it's good for low complexity apps though. So that kind of leads into Flux. So this is for people that are super into front-end development. This is probably, you're expecting me to get to this the entire time. Facebook, after building React, was looking at this last pattern, this having indexing and doing all this shared stuff. And they said, this is not working. This is not working for us because we're running into those situations where adding new features causes a mess, spaghetti code. We can't figure out how things are working. And so they said, hey, how do we fix this? The example they use when they're talking about Flux is their chat system that they have. They first started with the normal, just small chat box, and then they added chat notifications, and so they had to modify their application to include that. And then they added another chat box that was bigger, and then they had to add that in, and it just became this giant balloon that they couldn't manage. So Flux was born out of that. The Flux architecture, we're now backing away from MVC, and this is when we started developing architectures for SPA applications for the problems instead of trying to adapt previous architectures. So the Flux architecture, you have a view, which is your component. That view, that component, can fire an action, which is then picked up by a dispatcher, which then basically says, okay, what stores are interested in this action? And then it provides that action to those stores. The stores have been updated, and the view picks up the updated values from the store. So the biggest concept of this that's carried out through a bunch of other frameworks is this unidirectional flow. If we looked at the other diagram, we had two-way communication, and that causes some problems. So this is a unidirectional flow. The only thing that can modify the store is the action through the dispatcher. And then the views just read the store and update from that. Flux still kept multiple stores, so this is a simplification of that. So there would be multiple stores for different things. And because of that, people started thinking about this and saying, hey, let's just build our own framework based off of Flux. Because Flux isn't a framework, it's a pattern. It's a way of implementing something. So from Flux, this is kind of where we're at today. We have as many state management frameworks as we do just general JavaScript frameworks, it feels like. The biggest one of which is probably Redux. It was the one that started to gain a lot of momentum, and then we have things like NGRX and NGXS, which are based heavily off of Redux, as well as Vuex. So Redux is the last thing I'm going to talk about as far as strategies. And I'm a little partial to Redux. I really enjoy Redux, but it has a huge drawback that I'll talk about at the end. So how does Redux differ? Well, we drop the dispatcher, and now we have a reducer. So the biggest thing between Redux and Flux is that now there's only one store. There's a single source of truth. Everything goes into that single source of truth. So again, we have the view. The view can create an action, like whenever I created a to-do, that creates an action. That action goes into a reducer. The reducer is this basically case statement. It says, well, you perform this action, and this is the current state. Well, okay, we take those two values and we say, what's the new state from that? And the new state's calculated, it's put to the store, and the view is updated from that. What's it good for? High complexity apps. So you get to things that are super complicated, and apps with many moving pieces. So because it's immutable, and the only thing that can update the store is the reducer, it makes it a lot easier to handle all of those complex interactions between components. You know where to find things. It goes back to that organization. You know where to find what's updating the store. You go look at the reducer because it's the only thing that's supposed to be updating the store. Advantages: single source of truth, immutable, and extendable. There's tons of middleware out there for Redux. Disadvantages: lots and lots and lots of verbose code. Boilerplate, oh my goodness. And it can add more complexity if you're not careful. There's a reason why I'm not advocating for using Redux on everything. It's kind of like using, what's the saying, driving a Ferrari to the grocery store. So I got a demo again. This is the exact same to-do app that I used before. Slow. So same thing, not a whole lot of difference. You can do the same thing. Get talk, add. The only difference this time is now we're using Redux instead of a global variable. I apologize for how hard that is to read. If you want to see the code afterwards, you can come see me and I'll show you on my laptop. So we have the initial state up at the top. It's very similar to what we have with the globals. And then we pipe that into a reducer, we initialize that, and then down here we create the store from that reducer. You can see the reducer, it's that case statement. Right now we only have one action. If I was to flesh out this to-do list, you would have more than just add to do. We have complete to do, delete to do, and each of those would modify the state and return the state as a new object, immutable. One of the best things about Redux, because you can have apps that are super complicated, is the dev tools. If you do anything with Redux, this is a must download Chrome extension. It allows you to see all the actions that are happening in your application. It allows you to catch things. Maybe you have a component that for some reason is calling an action it shouldn't. And then it'll actually show you the diff between the state whenever that action updates it. It will turn green. The icon in the browser will turn green when you actually hit a website that has Redux. Going back to those sites I showed at the beginning, TurboTax, Reddit, Todoist, and StackBlitz, all of those use either Redux or some library that supports the dev tools. So you can actually go in and look at those websites and see all of their actions and what's going on behind the scenes. It's pretty cool. Boilerplate and complexity. So I want to harp on this just a little bit more because if you go out, it seems Redux is Flux was like 2015, so in technology terms, it's been out for a long time. But it's still kind of the hip thing to do, but there's a lot of boilerplate. If we go back to the to-do app, when we compare it to just using the global state, we've added like 20 lines of code to do the same exact thing that we had before. Granted, it's a lot easier to manage what's going on, especially if it's a super complicated site, but adding Redux to an app that's really simple will only complicate it. You'll have tons of boilerplate, verbose code, and if you can do it with one of the other strategies, the only thing you're gaining is the ability to extend it. So that kind of comes in with thinking about, okay, where is this app going to be in the future? Are we going to continue building upon it, or is it just going to be this small feature set and that's all we want? One of the ways, I just wanted to mention this real quick because I am an Angular developer. One of the ways, funnily enough, that NGRX is trying to resolve some of this complexity is by actually, there's still a single source of truth, but it's kind of broken out into multiple stores that are then all added together so that you can keep track of what is going on. So like your entire app isn't all in one reducer. You have separate reducers that all get kind of baked into one. The future. So the future, I think, this is, I guess, opinion time. Well, this whole talk's opinion. But I think in the future, the next thing is a trend towards trying to get rid of the boilerplate because as developers, we all know, we hate writing a bunch of code. We're lazy, or the best developers are lazy developers because we want to reduce how much code we have to write. So there's a lot of efforts within the different projects. NGRX is working on removing boilerplate, although they try to spin it that it's not boilerplate. And then there are also other libraries. If you're curious, you might check out Apollo, which is using GraphQL query language to store local state. So I think in the future, it's going to be about reducing the boilerplate even more than what it already is. So that's the code links. If you wanted to take a picture, or I can give them to you after the talk if you want to come see me. Are there any questions? We have a little bit of time. Are there any questions? Hopefully I didn't confuse everyone.
So I was just wondering about the strategies you went over. That pretty much applies in other realms, like mobile. I mean,
yeah.
Your opinion.
Well, I know, so disclaimer, I've done basically no mobile dev. So maybe someone else in the room that has done a lot more mobile dev might have some insight into that. I know that React Native, you use Redux in that. I think it's still, I mean, state management is just as important, but I don't know how it differs, especially with native development.
It's the same thing for you.
Okay.
We have some middle ways to manage all the reducers and actions. But the store works is
Okay.
And it is possible to do mobile development without Redux if you're working with just something that's simple.
Any other questions? Anything I missed that anyone wants to bring up? Anyone have something cool? No? Okay, well, I just want to say thank you guys for, this is my first conference talk I've given. They put me on the big stage. It's a little intimidating. Hopefully I didn't bore you guys too much. And I want to say thanks for supporting the local developer community. I think it's great that we have this. I'd love if we had this in the future. So thank you guys. Have a great day and enjoy the rest of the talk.